Please welcome Roland Lauster, Technische Universität Berlin.
So my name is Roland Lauster and I'm just retired. I'm happy and proud to nominate Cellbricks Incorporation. The story behind that is quite simple and quite short. So it happened a few years ago, several years ago now, that one of my PhD students entered my office. He closed the door, took a deep breath and said, I'm working now on my project since 2.5 years on immunology. I would really like to stop it right now. Because I would like to stop it, because when I come home in the evening, I'm not reading papers on immunology anymore. I'm sitting in my kitchen and I'm constructing and building up 3D bioprinters with my hands. This is my vision. And my vision is to construct a printer which is not only printing a certain scaffold, but which is printing human living cells together in the printing process. So now I took a deep breath, because this never happened to me before and not later anymore. And after a minute I said, do it. If your heart is beating for that, do it. So I'm happy that I made this decision, and I'm happy and proud to introduce Doctor of 3D Bioprinting, a real entrepreneur, Lutz Kloke.
Breaking the wall of replicating human tissue. Lutz Kloke, Cellbricks.
Thank you very much, especially for the kind introduction. I'm Lutz, and I'm happy to introduce Cellbricks today. Cellbricks is a Berlin-based medtech company that is using synthetic biology and bioprinting to replicate vital human tissue. I'm going to explain in a second how this works. Let me first tell you why I think this technology will be part of everyday medical canons in the future. The problem with transplantational medicine is that we rely on artificial materials like metals, plastics, ceramics, or on donor organs or animal-derived materials that require a lifelong immune suppression. But on the other hand, we grow older and older. You know, our body is made for a lifespan of 50 to 60 years, suddenly we become 100. So there's a huge demand for the replacement of life-sustaining tissues such as livers or kidneys, or even just functional tissues, like soft tissue, for example. But our current medical technologies are not really prone to cope with this problem. So there's a huge demand, and I think the numbers are quite high, so everybody in this room personally might know somebody that has to deal with this problem. And I have to believe that bioprinting can be a part of the solution to this problem. Now, 3D printing has been there for 30 years, and now you ask me where are the printed organs yet. With all things in biology, it's not that easy in a way. So if you want to print vital tissue, you have to tackle 4 major obstacles. First, you have to print with a micrometer precision, because all the functioning are happening on a cellular level. Second, you have to print with multiple materials, because apparently we are made from more than one cell type, right? And you have to work with human-like extracellular matrix. So you have to be able to print not with plastics, but you have to use collagens, hyaluronic acid, and all those other materials together. And the fourth part is you have to do everything very, very fast, because you don't want to put a lot of stress on your cells. At Cellbricks, we have tackled those problems. So first, we are using synthetic biology to replicate the extracellular matrix. So we have trained yeast that produce those collagens and hyaluronic acids, and we can farm them in fermenters so that we can use this material to create, which is basically the glue for our prints. We have gathered years and years in experience in designing and producing those mini organs. So I'm going to show you our track record later. And we developed a proprietary bioprinter, which lets us print with multiple cell types and multiple materials in one print run. And of course has a micrometer precision. The technology is based on stereolithography. The short version for you is I'm not using extruders. I'm just using light or light projections to cure everything. And this is a very fast and gentle process. And by the combination of all those things, you can see it looming there already, we managed to print already vital human tissues, such as cartilage, such as liver, or for example, bone. But on the other hand, also tumor models, for example, for drug development or CAR T-cell development. It would be way too much to go into detail into all those publications. I just want you to take home from this slide is that our technology is already working and out there and is all peer-reviewed, published. So it's no, let's say, no startup bullshitting in a way. How does our future look like and how do we take it from here? So we are taking it right now from a lab-based level to a next level. So we are cooperating with industry and we are doing an iterative process. So our next product will be soft tissue for implantational use. So in the future, if you had, for example, an accident or surgery, we'll be hopefully able to replicate the human soft tissue and implant it into your body to replicate the human soft tissue. And this is the next step to take it further on the road to a biofabricated organ. And the next step will then obviously be life-sustaining tissue. And this was basically the short speed run through Cellbricks and its technology. Thank you very much.
Questions? I do not see question marks. Ah, where? He, oh, well, you know, he was first. I'm sorry, he was faster. And he had a question mark.
It's a quick one. Where will your cells come from you're going to print? Once you're going into a cell, including material.
Okay, our journey, we took it from the last 4 years. We did bootstrapping, for example, for industry and printed for Robert Koch and B-Farm and so on and so on. The next step will be a medical device. So we're just going to use the material and check on the material and do all our certifications on the material. So the soft tissue will be just a soft tissue. No cells from the patient because the regulatory process benefits me if I do a medical device first. And from that, I'm going to go into ATMP business. That's with cells, basically, way harder regulated. And those will be the patient's derived cells.
Okay. Next question is 2 rows behind. Yes?
Thank you very much. Do you have a business model already, or are you still working on that? And can you talk a little bit about the approval process?
Yes. So the last 4 to 5 years, we did bootstrapping and we cooperated with industry and did basically printing as a service. So apparently, you guys are also from venture capital. This doesn't scale very well. So, so we did a seed funding round to basically develop our material portfolio. This is where the recombinant material comes in, where all those, because in the beginning we printed with animal-derived materials like porcine, bovine material. But if you want to put it into the human body, you need to basically regulate it and you want to control it. Thus, recombinant technology kicks in because it's you can basically monitor it very well. This material, so we have to do 2 ISO certifications, one on us, ISO 13485, and one on the material, ISO 10993. And then this material will get a CE certificate and we can put it into the body. If we do it with cells, then we have to apply to basically all those, then we are regulated as a drug, and the regulation process will take much, much longer. But now with a medical device, we are talking about a regulatory phase of 3 to 4 years.
Okay. Yes, absolutely.
One dimension that I haven't heard addressed is the dimension of data. I think this completely new approach to biofabrication also allows the generation of data that we haven't experienced so far in understanding biology.
Yeah.
Do you have an approach to systematically collect the data on your material? That would be the question.
Yes, we do this. And we did a project together with the University of Potsdam, where we built a so-called, let's say, organ generator. It's just made looking at vasculature, because in the beginning, if you want to print something big, you need to get those nutrients in and all the waste out. So you need a vasculature. It's basically the holy grail of bioprinting. And in the body, there's an oxygen diffusion barrier of something like 400 micrometers. So you know that there's a rule that there has to be a vasculature within 400 micrometers of your cell type of thing. So we built basically, knowing from this data, we built basically a software system that generates vasculature into any given object that you throw on the software. So you can basically do all types of shapes and tell them, look, build me an vasculature into this mini organ.
Okay, very last question.
Yes,
Thank
we were
you.
talking about the hardest problem that you had to solve. For me, it would be good to understand where your company, where Cellbricks really had the biggest breakthrough.
Or in the beginning, I thought it's the technology, and when I had the printer, I thought like, okay, that's it. But that's not it. It's just the beginning. The hardest part is bringing everything together, the knowledge how the organ works, the material, how it has to be printed, how the printer has to be handled. It's the combination of all things together where all the blood, sweat, and tears came from. It's not the technology as it was. When I went to Roland, I thought it's just a printer, but that's where it all started.
Okay, thank you very much.
Thank you.